Welcome to Space Enigmas, where I explore the greatest mysteries of our universe through extensive research and analysis. Today, I'm sharing my investigation into one of humanity's most profound questions. Are we alone in our solar system? Mars, the red planet. When I first began researching our cosmic neighborhood, I was immediately drawn to this enigmatic world. During my exploration of astronomical history, I discovered that Mars has captivated human imagination for centuries in ways no other planet has.
What's particularly fascinating about Mars is that it sits in what astronomers call the Goldilocks zone. Not too hot, not too cold. Based on the geological evidence, it had all the ingredients necessary for life during its early history.
What fascinated me most during my research is how scientists' attitudes have changed. If they once asked about life on Mars with a skeptical smile, today I found they're more excited than ever. Why? My investigation has uncovered what Mars rovers have discovered on the red planet and why these findings might soon revolutionize our understanding of life in the universe. While diving into historical archives, I traced our obsession with finding Martians back to 1877, when Italian astronomer Giovanni Schiaparelli observed strange lines on the planet's surface, which he called canali, or channels. What's fascinating to me is how quickly this scientific observation transformed into public speculation about an advanced civilization.
The misinterpretation of canali as artificial canals rather than natural channels is a classic example of how our desire to find extraterrestrial intelligence can influence scientific interpretation. The American astronomer Percival Lowell further popularized this idea, publishing detailed maps of supposed Martian infrastructure.
Looking at the progression of Mars exploration, I noticed how dramatically perceptions shifted when the first spacecraft reached Mars in the 1960s and 70s. The mariners and Vikings showed what appeared to be a lifeless desert covered in craters. Vikings even conducted experiments to look for microorganisms in Martian soil, but when analyzing the data myself, I found the results were far more ambiguous than most people realize. In my analysis of fundamental requirements for life, I've identified liquid water as the most critical element. What's remarkable about the last 20 years of Mars research is the overwhelming evidence I have uncovered showing Mars was once a wet world.
Water is indeed the universal solvent that enables the chemical reactions necessary for life as we know it. Without liquid water, the complex chemistry of life would be practically impossible. The discovery of water's history on Mars is arguably one of the most significant findings in planetary science.
When examining the Opportunity rover data, I discovered minerals that could only have formed in the presence of water. My further investigation of Curiosity's findings revealed rounded pebbles, characteristic of riverbed formation, something that's impossible without flowing water. After analyzing multiple geological surveys and rover data, I've observed a fascinating pattern. All evidence points to Mars having extensive oceans, rivers, and lakes about 4 billion years ago. What's particularly interesting in my analysis is how the timeline coincides precisely with early Earth's development.
To put this in perspective, 4 billion years ago is exactly when we believe life was first emerging on Earth. If similar conditions existed on Mars during the same time frame, the implications are profound for understanding life's potential throughout the cosmos.
You might wonder, as I did during my research, if Mars was once so Earth-like, where did all that water go? And more importantly, was there life in it? These questions led me to the next phase of my investigation. One of the most significant discoveries I came across in my research happened in 2018, when the Curiosity rover found complex organic molecules in Martian soil, billions of years old. While reviewing the scientific literature, I realized something important that isn't emphasized enough. These aren't definitive proof of life. but they're exactly what we would expect to find if life had existed.
The organic molecules discovered by Curiosity include several ring structures and compounds containing up to 12 carbon atoms. On Earth, such complex organic compounds are typically associated with biological processes, though they can be formed abiotically under certain conditions. What I found particularly intriguing was the mystery of methane in Mars's atmosphere. In my study of Earth's atmospheric composition, I learned that most methane is produced by living creatures. When I looked at the Mars data, I noticed something remarkable. Its concentration mysteriously fluctuates by season. Connecting these data points led me to question, could this be geological activity or something more profound? Perhaps the breathing of a Martian biosphere? While NASA reports mention these findings separately, my analysis suggests these pieces fit together in a compelling pattern that deserves more attention.
The seasonal variation of methane is particularly telling. On Earth, we'd interpret such cyclical changes as biological in nature, while there are geological explanations such as methane being trapped in subsurface ice and released during warmer periods. The biological possibility cannot be dismissed. A question that kept resurfacing in my research: if life did exist on ancient Mars, could it have survived until today? After examining extremophile research on Earth, I believe it's possible, but likely not on the surface. In 2018, I came across a groundbreaking study where Italian scientists, analyzing radar data, discovered an entire subglacial lake of salt water beneath Mars' south pole. What many reports missed, but I found significant, was that several similar bodies of water were later found nearby, suggesting a more extensive subsurface water network than initially reported.
These subsurface lakes are particularly exciting because they are likely extremely salty, what we call brines. The high salt content lowers the freezing point, allowing water to remain liquid despite Mars's cold temperature. On Earth, we find thriving microbial communities in similar hypersaline environments, from the Dead Sea to deep Antarctic lakes like Lake Vostok.
During my comparative analysis with Earth environments, I discovered remarkable parallels. We find life in similar extreme environments on our planet, from Antarctic subglacial lakes to the deepest mines. The microorganisms, called extremophiles, show incredible adaptability that, in my assessment, could theoretically exist in Mars' subsurface environments. Additionally, my investigation into Martian soil composition revealed the presence of perchlorates, salts that can lower water's freezing point. This means that even today, thin films of liquid water could periodically form on the surface, a detail that I believe has profound implications for potential microbial habitats. In my timeline analysis of Mars exploration, I identified the Perseverance rover mission as the critical turning point in the search for life. When I studied NASA's mission planning documents, I realized its main task isn't just to look for traces of ancient life, but to collect samples that will eventually be brought back to Earth.
The sample return mission represents the holy grail of Mars exploration. While rover instruments are impressive, they can't match the analytical capabilities of Earth-based laboratories. Once we have actual Martian samples in our labs, we can apply techniques like high-resolution mass spectrometry and advanced DNA sequencing that are simply impossible to perform remotely.
What I found most compelling about the landing site selection was Perseverance's touchdown in Jezero Crater, an ancient lake with a river delta. In my research on Earth's biodiversity hotspots, I discovered that river deltas are exceptional environments for preserving organic matter. This strategic choice, in my analysis, significantly increases our chances of finding preserved biosignatures. After reviewing the technical specifications, I was impressed to find the rover is equipped with the most advanced scientific instruments ever sent to another planet. Based on preliminary data I've analyzed, it has already discovered organic molecules in Jezero Crater rocks, findings that align with my hypothesis about potential biological activity. You might be wondering, as I did during my research, when will we finally know if there's life on Mars? Based on my analysis of mission timelines and technological development, I believe the question could be answered within the next decade. In my investigation of space agency planning documents, I found that NASA and the European Space Agency are developing a mission to bring Martian samples to Earth by 2033. This represents, in my assessment, our best chance yet to definitively identify biological signatures.
The Mars Sample Return mission is arguably the most complex robotic space mission ever attempted. It requires multiple launches, a sample collection system, a Mars ascent vehicle, and a secure containment system to protect Earth from any potential contamination. The technological challenges are enormous, but the scientific payoff would be revolutionary.
When considering what we might find, my analysis of extremophile biology suggests we're likely not looking for little green men, but microorganisms, if they're there. They might differ from Earth life, but based on my study of biochemistry, they will likely use the same basic chemical language, DNA or RNA. What fascinates me most, and what I don't see discussed enough, is that even finding remnants of ancient microbes would revolutionize our understanding of life's prevalence. Because if my analysis is correct and life originated independently on two neighboring planets, it means the universe could be teeming with life. After compiling all my research and analysis, I've come to realize that searching for life on Mars isn't just scientific curiosity. It represents a fundamental question about our place in the universe. If you found my analysis valuable, consider subscribing to Space Enigmas to join me on future explorations of space's greatest mysteries. Next week, I'll be sharing my discoveries about black holes and the secret they hide that could completely rewrite our understanding of physics. You won't want to miss it. What do you think about these Mars discoveries? Share your thoughts in the comments below.